Hi, my name is Jennifer.
I'm Roxana. I'm Karina.
I'm Jessie.
And our topic is energy management. So these are the definition of the terms that we have. We have a lot, but we'll kind of explain as we go through the PowerPoint. So the first one is LEED, which is Leadership in Energy and Environmental Design. And GHG is greenhouse gases. And if you don't know what that is, it's when the gases are trapped, when the gases trap the sunlight and the heat gets absorbed into the earth, such as carbon dioxide. And then MW is megawatts. CFL is compact fluorescent lamp. HVAC is heating, ventilation, and cooling. HP is horsepower. VAV is variable air volume. T8 is for fluorescent lamps. The T describes the tubular shape, and 8 is the size. Ballast is the device used to limit the electric current in the light fixtures, and then HID is high intensity discharge.
Okay, so I'm going to talk about just strategies in general that are used in food service. And first, I'll start off by saying that the largest portion of energy used is consumed by cooking and food. As you can see, I think it's right here. It's 24.4% of all the energy used in food preparation. And then it's closely followed by heating, ventilation, and cooling as a whole, so HVAC, and you can see that over here. And together, it makes up a little bit more than 50% of the total energy usage just in those two areas. And then we have the lighting and the sanitation and the refrigeration that make up pretty much the rest. Okay, so the first strategy is to use Energy Star qualified equipment. And from their website, the Energy Star label appears only on equipment that meets strict energy use guidelines and assures the buyer and appliance is among the top of energy performers in its class. And this is the list from their website. And their equipment includes dishwashers, fryers, griddles, hot food holding cabinets, ice machines, ovens, refrigerators and freezers, and steam cookers. And the pros to using Energy Star qualified equipment is that there are many rebates available when you purchase these. They're very easy, and they are very easy to implement. So you just install them, and they pretty much do all the work. And the cons is that you must be in the market for new equipment, or else if you're just trying to change all of your equipment, then it might be a high cost. Okay, another thing that you can do is the choice of equipment. So it's not just buying Energy Star equipment, but also choosing certain types of equipment that will reduce energy. So the first one is connectionless or boilerless steamers, and I think they were mentioned earlier in another presentation. So they use less energy and less water than other gas or electric steamers, and they can save up to $1,500 on electric bills. And there are rebates for them up to $750, but it's just on certain ones, it's not for all of them. And then other equipment is the combination oven, which combines a steam and hot air convection oven, and it reduces the need of multiple appliances, and you can get rebates for up to $1,000. Then there's also the hood demand ventilation controls, which are DVCs, and they are a system that controls the speed of hood exhaust and make up air fans by using variable frequency drives to reduce hood energy consumption during idle periods. So practically it just turns things down when it's in an idle mode or if it's not really being used. And qualified systems are eligible for rebates up to $350 per exhaust horsepower. So that's very interesting. And then another thing is induction ranges and walks. So for certain food service places, they reduce heat produced and therefore also lower conditioning and ventilation needs. And another thing that I forgot to add is that they also keep the area cleaner, so it reduces the need to clean the area as often, which also reduces the water and then energy in that aspect. So something else is an energy management system. This is a computerized method of managing all energy being consumed in an establishment. So what it does, well, this is a direct quote. So it enables business users to easily view and reduce their resource consumption in a real time with the mere touch of a button, resulting in utility bill savings upwards of 20% or more per month by allowing them to control equipment cycles and maintenance. And usually to install it, it costs around $2,000 and then a monthly contract of $50. And what it really does, it just, in a computer, it just puts in all of the information of all the equipment that's being used, and then you can just easily monitor it and see what's being used, what uses more energy, what maybe you could do to lower the energy. So it just, so the pros, it reduces energy costs, it reduces environmental impacts because it's all in a computer, and better uses existing energy consuming assets because you're able to monitor it all. It creates transparency because anyone can see it, and it facilitates energy management improvements in the context of greenhouse gas emissions reduction projects. So it's very easy to use and very simple, and it's very and it helps reduce energy costs. And then the cons is that all the things that it does can also be done with standalone systems, but it's just more convenient. And it only mainly helps reduce energy costs of HVAC. So it doesn't really take everything else into consideration. And then something else is a comprehensive energy management. So it is a program that measures every watt of energy used in a facility, and then it implements sustainability programs or updates equipment and facilitates to reduce energy consumption. So it's similar to the EMS, but this one integrates all other aspects and not just mainly focuses on the HVAC. And there are some certifications available, so you can take a course and it can teach you how to do everything. So that's interesting. So pros, it's very simple to operate and it's low cost, so it can be done even with a simple spreadsheet. It's just very time consuming, and you have to be updating your information constantly.
Now I'll be talking about the UC policy on sustainable practices. So they want to integrate energy efficiency and sustainability into projects on UC campuses. And they also want to limit and reduce the usage of non-renewable energy sources, such as using fossil fuels. And they also want to encourage alternative transportation, as well as increasing living on campus. That way you reduce the amount of gasoline being used. And they also want to record and minimize greenhouse gas emissions from university operations. So this is the strategic energy plan. They have a goal to reduce energy usage by 10% by year 2014, starting from year 2000. And one approach is to reduce greenhouse gas emissions, which is 75% used by electricity and gas, to year 2000's level by 2014, and to year 1990's levels by 2020. So the energy saving projects include lighting, HVAC, central plant measures, but the ones that we will focus on is lighting and HVAC. And as a side note, one of the campus-wide projects is to replace pre-2001 refrigerators with Energy Star units, and supposedly Energy Star claims to use 15% less energy with their refrigerators. So lighting, they want to replace the T12, so tubular 12 refers to the size, and the 32 watt T8 fluorescent fixtures to 28 watt T8 lamps with energy efficient ballasts. And ballasts are used for limiting an electric current, and you can see right there. And they also want to set up sensor controls and daylight harvesting and new stairwell fixtures in order to conserve energy, and also replace the interior high intensity discharge fixtures with fluorescent ones, as well as switch the parking structure lighting to fluorescent lamps. So HVAC, heating, ventilation, and air conditioning or cooling. And the goal is to have air handlers that are 10 horsepower and above to meet efficiency standards by air volume, control of economizers when needed, using digital controls, demand control ventilation where necessary, static pressure reset, and this system is used in laboratories and kitchen hoods. So specifically in the kitchen for ventilation controls, the problem is that as Roxana mentioned, the standard kitchen hood exhaust fans run constantly using maximum flow of required air to be heated and cooled. So the plan is to install variable air volume hoods to be controlled by infrared and temperature sensors, so that when there's no cooking, when it's not being used, like there's no cooking activity, it would be turned off, and this saves a lot of energy loss between meal preparation.
So Cuarto was renovated recently, and when it was renovated, they made it so that it could meet the standards for gold level LEED certification, and it's our only dining common that has that. So they wanted to, one of the goals of LEED is to be more energy efficient, so they added new equipment, they designed it so that there was more natural light, they had mechanical systems improvements, they reduced energy use through high efficient lighting and the natural light that they had. They wanted renewable energy, non-chemical water treatment systems, heat, solar recovery system from the boilers and the pumps, and then lighting control integration and recycled content and stuff like that. All of our dining commons are actually Sacramento Area Sustainable Business certified. And one of the main categories for it is energy conservation and green buildings. So they include energy efficient lighting, HVAC, which we just talked about, energy efficient appliances, and green buildings with good insulation and natural lighting to save energy. The dining commons here want to reduce their global impact, so they're doing this with turning off the appliances when they're not in use and making sure they're clean so they're functioning well, replacing the incandescent bulbs with the CFLs, which will save energy through the fluorescent lights, hood vent and smoke sensors to minimize energy impact, individual light switches, automated lights, and other light reduction practices to save energy. They're also looking to reduce their uses of fossil fuels, so they're using electrical vehicles to transport things on campus when possible, decreasing their food waste so they don't have to transport it as much, researching different types of biofuels, and using local farms and student farms when possible so that they don't have to use as much fuel to get the food here. At UC Santa Cruz, all of their dining commons are actually LEED certified. They designed it well with architecture so that it had natural lighting, it's well insulated for heating and cooling, and they're using other energy efficient systems. They are looking to continually improve, and they actually raised over $1.25 million to pay for their eco-friendly continuation and additions to buildings. So they're trying to increase sustainable food, getting it from more local sources to cut down on fuel costs, and they want to increase that sustainability to 25% by 2013. They want to reduce their greenhouse gases to levels from the 2000s. They want to generate 1 megawatt of on-site energy, and they want to improve energy and water efficiency in all of the dining halls.
So now that we have covered UC system and UC, I'd like to talk about 2 examples beyond that. So the first example I chose, I want to talk about McDonald's and what they've been doing to better manage their energy usage is they use a special fire called a low oil volume fire, LOV, and they use it to make more efficient French fries. And this type of fire cooks about the same amount of product but uses approximately 40% less oil. And since the volume of the oil is less, you're using less energy to heat up the oil versus if you were to heat up like a larger gallon of oil. And this fire design improves cooking efficiency and it requires less maintenance, which thus decreases the amount of energy usage. And McDonald's, as we mentioned earlier, we talked about EMS systems. McDonald's also incorporates the use of the EMS system, and just to reiterate, this system controls energy usage in the restaurant facility, and it helps automate the on and off function of HVAC and exterior lights, and this helps save up to 10% of the restaurant's energy use while ensuring a comfortable environment for customers and the staff. And McDonald's is currently evaluating the possibility of expanding items controlled by the EMS to include kitchen equipment. And in 2009, McDonald's in China set up a goal to reduce utility costs by 5% over the previous year, and they're doing this by optimizing HVAC and lighting systems and investing in more energy efficient equipment, and standardizing maintenance and auditing protocols. And they also use energy zoning and 3M solar pump, which is a type of tinted panel, and it helps reduce the heat loads and energy consumption while also improving the atmosphere for the customers. And the second example I'm going to talk about is Starbucks, and Starbucks actually set 2 goals for themselves. And one is to reduce energy consumption by 25% and to also cover 100% of energy consumption with renewable energy by the year 2015. And what they're doing to reach those goals is they're planning to replace existing equipment and appliances with higher energy alternatives as they reach their useful life, and also incorporate the usage of LED light emitting diode light bulbs, which is an efficient type of light bulb that significantly reduces energy consumption. And Starbucks also uses the energy management system, EMS, and they use it in nearly 700 company stores throughout the US, and this drastically reduced the HVAC consumption by about 20%. And as you can see here by this chart, the measures that Starbucks has been using helps to increase the electricity usage by more than 70% since 2009. And hopefully their goal by the year 2015 is to decrease it by 25%. And in conclusion, energy management is essential to food service facilities because it reduces energy costs and it's also beneficial for the environment.
Do you guys have any questions?
I was just wondering, I don't know if you covered this, but did you find a lot of information about like solar panels, like how much energy it could regenerate just from, because I know like in West Village, they have some solar panels, right? Did you find any information on that?
There isn't that much, there wasn't that much, there's not many on campus. I don't think they really use it here. They use them for some of the lights, I think. The night lights are solar panel, but nothing really in the food system. Had anything about
Yeah,
solar?
we
We
did.
focused mostly on food service, so there wasn't much solar panel.
I would think Quarto would, I don't know, but I would think if it's gold, then they're using alternative energy, but it might be geothermal, because I know there's some geothermal on campus.
Yeah.
I don't know where.
And they use like a solar heat recovery system for like the high efficiency boilers and pumps. But besides that.
I know you guys said you focused on food service, but the lights, the street lights around Davis, did you find information on that? Because I know they're really dim, and I feel like Davis is dark.
Not the street
Yeah,
lights,
we
I
have
mean,
not
around
looked into-
campus.
Uh,
And in the parking structures, but now they're all automated, or a lot of the new ones are automated, and they're using new, more energy efficient bulbs, but we didn't look into the town Davis.
Also, the city of Davis, that's like a city ordinance to reduce light pollution more than it is an museum measure.
I noticed you talked about like the sensory one where they sense people and then the lights go on. But if you're working in a kitchen, I would assume like let's say we were working at the CSE, people are there like the whole day. So I don't see how much it works.
Well, like if you walk into a walk-in freezer, like, you know, you're going into different places, just, people aren't everywhere all the time. And also they have, put in more light switches, so you can choose.
And that factor was mainly for the campus rather than the kitchen itself.
I remember, from CSC, they use steam to power some of the cooking equipment. Is there any like other methods? It's like, is there any alternative methods? Like they use steam and then you use electricity, right? Is there like any other methods to power the other equipment, like solar power?
There's gas also, instead of,
But I think steam is much more efficient.
So you guys talked about the energy management system and how like 700 restaurants are using that system. Is any of the UC like using that or some sort of system similar to that to like monitor their energy usage? Do you guys know?
As of right now, I don't think so, but it's just a strategy that other businesses have been using.
So is it more like corporation, like big?
Yeah,
Yes.
like I said, Starbucks and
McDonald's.
McDonald's used it, but maybe in the future UC might consider it, but I think it's very like Roxanne said, because like very time consuming, requires like an investment.
Yes. And it can be done with standalone systems, and I think that's what the UC is doing.
It's kind of like a computerized thermostat at home that you set to go on and off at certain times. And so it's measuring the whole facility, and it, you know, the kitchen might be hot, the dining room might be cool, and so you can cross ventilate. And so it automatically goes on and off. And so they're expensive systems, but they save a lot of money. But at home, the best way to describe it is like at home if you have a little computerized thermostat for your heater. But it's more than just your heat.
For me, the example that came into mind when I was trying to figure out exactly what it was is I don't know if you guys have ever been to Disneyland. You know how there's like the that one house that like everything is like computerized, and like at the entrance you go, it's in Tomorrowland or something, and you walk in and then like it has a computer and it tells you everything that's going on with the house, exactly what's on, what lights and everything. That's practically like that's what it is, and it's all easy to manipulate.
A few more comments?
I was actually just wondering, for the 10%, how we're trying to reduce the energy use by 10%, how far are we on that? Like, is that a reasonable estimate or a reasonable goal for us at this point? Do you guys know how far along, like how much we've saved so far?
I'm not really sure on the progress actually, but that's just the known goal.